So we're working on 44A today, which is 21 through, was it 59? Odd. 29 to 51, 21 to 59 odd. So we look at number 21. How do you get rid of a square root? Square it. So we're going to square both sides, and I get u plus 1 equals 16, and I subtract 1, and I get u equals 15. Shem, everybody listen to Shem. You're so close. Let's plug this in. Let's plug 15 in there. Is the square root of 15 plus 1 equal to negative 4? No, it doesn't work. So if I were to set this up differently, and I were to say something like u plus 1 squared equals 16. How would I solve that? Square root both sides, and I get u plus 1 equals plus or minus 4. Right? So, I actually set this up wrong. But when you square root a variable squared, you get plus or minus. I think what I was actually going for is more like this. If I said, well, anyway, so if I had x squared equals 16, and I square root that, x equals plus or minus 4. And in this case, we have the positive version of the square root equaling the negative version of the answer, which can't happen. So in this case, I should have automatically looked at it and said, there's no solution. There's no point in even bothering it. So when do you have a square root equation that has no solution? When a positive square root equals a negative number. So if we look at number 22, does it have an answer? 22, we don't need to do 22, but it doesn't have an answer because a negative square root cannot equal a positive 9. So that would be no solution. Okay, what about 23? Let's say 23 equaled negative 3. Is that a problem? No. Can odd square roots, can you take the third root of an odd number? The third root of negative 8 is negative 2. So we only create imaginary numbers or run into problems with square rooting negatives if the root is odd, or sorry, is even. Wow, I can't think today. So what's the opposite of a third root? Third power cubed. So 5x plus 2 equals 3 to the third is 27. Subtract 2 is 25, divide 5. X equals 5. Hey, so Jessica's gone today. What sort of message should we leave her? A very vague one. Okay, Jessica, not Jesse. Okay, Jessica, the chicken is in the oven. Bake it. There we go. The cow is out in the shed. Fezzik is in the oven. There we go. She won't get that one. Okay. So, number 27. 25. Oh, well, yeah, let's do 25 first. Good idea. So, what is the 1/3 power really? It's the cube root. So really, this is just, oops, wrong one. This is just the cubed root. So we'd raise it to the third. Is that negative 1 a problem? No. Okay, so I'll let you finish that one. Look at number 27. What is going on with 27? What is the 5/3 power? Well, what if it said the 1/3 power? What would that be? the cubed root. What if it just said to the fifth? It would be just to the fifth. So this is the cubed root of x plus 3 to the fifth. Now, does that 5 belong on the inside or the outside? It doesn't really matter unless it's an even root. An even root, you run into problems with negatives. So it doesn't really matter if it's on the inside or outside, but if it's an even root, you have to check and see if you run into that negative problem. Okay? So if this equals 32, how do we undo the fifth power? The fifth root. Does 32 have a fifth root? Oh, sorry, fifth root. It's 2. 2 to the fifth is 32. So we have the third root of x plus 3 equals 2. Now what? Nope. Cube it. So x plus 3 equals 2 to the third is 8. We subtract 3. X equals 5. So let's look at 32. So essentially, we fifth rooted 32 and raised it to the third. So I took the 5/3 and I raised it to the 3/5. Right? That's how you get rid of a 5/3 exponent. You raise it to the 3/5. So over here on 32, I raised it to the 3/5, which is the fifth root of 32 to the third. So what it's saying is, can you split 32 into 5 equal multiplications? And how many of those 5 are in my answer? 3. So 32 to the 3/5 is 8. Yeah, you can just do that from the beginning, if that makes sense to you. If it doesn't, then just treat them separately. So if I had 8 raised to the 4/3, what would that be? So can you split 8 into 3 equal multiplications? 2. And how many of those 2's are in the answer? 4 of them. So we need to add an extra 2 or multiply an extra 2, so it'd be 16. Yeah, if it doesn't split equally, then the answer is going to be some nasty decimal, but I assume in all of these problems they will. So if I had something like 81, no, let's not do that. What about 27 to the 5/3? What would that be? Does 27 divide into 3 equal groups? So the answer is 3 to the 5th, so 81 times 3, which is going to be 243. All right, 29. So on number 29, what are you going to raise the 4 to? The 3/2. What is 4 to the 3/2? 8. 4 split into 2 equal multiplications is 2 times 2, but I need 3 of those, so it'd be 2 times 2 times 2, which is 8. Okay? No. So this is 2/3, but to get rid of that, I raise it to the 3/2. What is 2/3 times 3/2? 1. So those cancel, and then I do 4 to the 3/2, which is 8. Oh, sorry, this is one of those cases where there's an even one. Thank you for reminding me. So 4 to the 3/2. If I raise this to the third, do I need a plus or minus? No. But when I square root it, now I get plus or minus x plus 1 equals 8. Thanks for looking that up, Jason. So if your denominator Was it not Jason? Oh. We'll give Jason the credit. It's the first time he's ever had any. So if the denominator on the new exponent is even, you need a plus or minus. And you also have to worry about if it said -4, is that possible? No. Because you're square rooting a negative, which doesn't work. Okay, 31. Okay, 31's kind of tricky. So for number 31, what am I going to do to get rid of that square root? Square both sides. Now, that creates a potential problem. If x is negative, does this have a solution? No, because the square root of anything cannot equal a negative number. So when I solve this, if my answer is negative, I'll get an answer, but any negative answer won't work. Because if that number is negative, it's an impossible situation. So we end up with 12 plus x equals x squared. Now what should I do? Get them all on the same side. So x squared minus x minus 12. Factor that. X minus 4, x plus 3. So my roots are 4 and -3, but if I put -3 back into the original, well, right there, the square root of 12 plus x cannot be -3. There's another thing I also need to check. If I plug 4 in here, am I square rooting a negative number? So there are actually two things going on. First of all, does the square root equal a negative, which can't happen? And if I plug x in, does the original square root give an I? And in this case, no. So 4 is the answer for 31. If I got something like x equals 8 and -15, do those both work? Well, I can't put a negative in there, and actually, in fact, that takes care of itself. But if I put -15 in there, the square root of 12 minus 15 gives an I. So you kind of have to look on both sides and make sure that it works in both places. Okay. 33 you can do. 35 is the same. 37. We need to do 37. So, 37, I'm going to square this. How do you square x plus 3? So 2x plus 6, and this is, we need to distribute. Can you guys do that in your head? X squared plus 6x plus 9. Now what? Set equal to 0, so I need to move these two over. And I get x squared plus 4x plus 3. And then it gives me x plus 3 and x plus 1. So what are my roots? -3 and -1. Are those problems? Only if you plug them back in and they create problems. Just because they're negative doesn't mean that's bad. So if I put -3 in there, what do I get? 0. Can a square root equal 0? Yes. If I put -3 in there, is that a problem? It also equals 0, which is what we want, right? When we plug in -3, we want both sides to be the same. So that worked. What if I put -1 in there? I get 2. Do I also get 2 if I put -1 in there? 2 times -1 is -2 plus 6 is 4. Square root that is 2. So both of those answers work. Okay, 37. 39 is the same. 41. What would you do for 41? And I actually would probably, I would prefer for this to be positive. So I would move the 3 over there and move this over there and then square both sides. How do you square 6 square root of x minus 1? What is 6 square root of x minus 1 squared? It's going to be 36 times x minus 1, so 36x minus 36. Okay. So 43 is the same way, 45 is the same way, 47, 49 I think you can do. All right, 51, this is the hard kind. All right, these are not very friendly, but every once in a while it happens. Okay, so for number 51, we need to get rid of the square roots. And because there are 2 of them, it's going to take 2 squares to get rid of them. So pick the first one you want to eliminate and move everything else to the other side. So I'm going to add that second square root to the other side. Move this over plus the square root of 6x minus 5. Now if I square it, the one on the left will go away. So I square this, and I get 3x plus 1. That's not so bad. But now I have to square this one, which is kind of problematic. So that gives me 1 times 1 is 1. And the next 2 terms are identical. They're both the square root of 6x minus 5. So if I add those together, I get plus 2 square root of x minus 5. And the last one would be, if I multiply these together, I get plus 6x minus 5, because a square root times itself is just what's on the inside. Okay? Now what should I do? I got to move everything to the left side except the square root that's left and square again. Wait, what? Yeah, so sorry. I skipped a step. 1 times 1 is 1. That is root 6x minus 5. This is root 6x minus 5. And then that one gives me just 6x minus 5. So I need to subtract 1 and add 5. So that's 5. And I need to subtract 6x. So negative 3x plus 5 is equal to 2 square root of 6x minus 5. Should I divide by 2? I don't want to, because if you divide by 2, you're going to have a fraction, and you're going to square it and make it a worse fraction. So just leave the 2 where it is. So now I square both sides, and that gives me, on the left side, I get 9x squared. And this term times this term is negative 15, but I have 2 of them, so negative 30x, and then 5 times 5 is 25. And that equals 4 times 6x minus 5. So that would be 24x minus 20. Then I subtract those over and add that. So 9x squared minus 54x minus 45. Oh, they were nice to us. I can divide it by 9. Do I need that 9? No. Dividing by plus 45. Thanks. Dividing by 9 will change the graph, but all I care about in this case are the roots. So dividing by 9 gives me x squared minus 6x plus 5. So that's going to be x minus 5 and x minus 1. So my roots are x equals 5 and x equals 1. And then I have to look back at the original equation. It was number 51. So I just need to check, do 5 and 1 work? So put a 1 in there. 3 times 1 plus 1 is 4, so that would be 2, minus, put a 1 in there, 6 minus 5 is 1, square root of 1 is 1. Does that work? Yes. Try the same thing with 5. That would be 15 plus 1 is 16, excuse me, 4, minus 30 minus 5 is 25, and square root of 25 is 5. Is 4 minus 5 equal to 1? No. So this is not a correct solution. Okay? Let me look at the last couple. 53 is the same. 55 is the same. 57 is the same. And 59, I think you can handle 59 now. So squaring it will eliminate that. And we'll eliminate that. So this, and then you have 2 plus root x equals x. So you're just going to, I wouldn't square it here. Move the 2 over and then square it. Okay? But is there another one that also works? So I would solve it all the way out before you finish it. So thanks for listening, Jessica. We hope to see you tomorrow. Good luck.